Okay, so let's kind of wrap this up because we've already done a lot and there's probably close to 30 minutes of videos, which normally we're in class for an hour and a half, but that's just a lot. So trying to break it up into little pieces and give you guys a chance to go stretch your legs and take a little break. So hopefully you're kind of wrapping your head around the distributive property a bit. It gets a little more complicated when we start adding expressions that have variables. So we're going to talk about what about variables, what about negative numbers, what about fractions. So you'll notice I already set up what about variables and I gave you the expression. And so we're going to talk about how do we go from this expression of 2 times 9 plus p, remember because it's in parentheses, and we have a factor outside of it. Our definition said that we're going to multiply our factor by both numbers inside the parentheses. So I'm going to multiply 2 times 9, and I need to multiply 2 times p. Okay, that's what our distributive property is. That you get the same exact thing. It's equivalent if you were to add these first and then multiply by the outside number, which we proved that in the examples we just did. Or if you just one at a time, multiply 2 by the first number and then multiply 2 by the second number and add them together. So if I multiply 2 times 9, I'm going to write this out in expanded form. I'm going to write 2 times 9. Sorry, I almost went to solving it. Sorry. Okay, and then I'm going to add, because this is an addition problem, 2 times p. Now we don't write 2 times p with a multiplication sign. We've talked about in class that in algebraic expressions, you just write 2p, and that means 2 times p. And we did some practice where you guys were substituting in, like, matter of fact, y'all just did this homework on Wednesday, where you're given a value. No, I take that back. Oh, I don't remember. It was before the break. You guys did the practice where they give you a value and then we did it on. I'm so tired. Anyway, where they give you a value and you substitute it in for the variable and then multiply. So you've seen this before. Okay, so then the last thing that I'm going to ask you to do is take this expanded form, and I'm just going to come below it here, and I'm going to evaluate instead of rewriting it to save some space. Okay, I'm going to evaluate it here. So this is expanded, this is the original expression, and then we're just going to evaluate it over here to save some space. So now I'm going to go ahead and do 2 times 9, which is 18, plus 2p. So that is as far as I can go in evaluating it. I can't do anything else unless I'm given a value for p, right? So some of the ones that we practiced, it was like, evaluate this expression if p is 2, or evaluate this expression if p is 4, whatever. But at this point, that is the final answer. That is 2 times 2 times 9 plus p is equivalent to 18 plus 2p. Seems weird. Okay, so let's try another one. Let's see here. Oh, why did I do that one? Oh, here we go. Okay, let's try another one. This one we'll use an x. So if I do 5 times x plus 1, okay, that's my expression. Now I'm going to expand it over here. So I'm going to multiply 5 times x. 5 times x. Oh, wait, I don't need to write 5 times x. Isn't 5x all I need to write? Isn't it? Because if I come over here to the side and do 5 times x, that's just the same as 5x. Yeah, so that's all I'm going to do there. Okay, and then plus, because this is an addition expression, 5 times 1, which is 5. And this is expanded, right? Actually, you know what? That's really not expanded. That's actually really the evaluating it. I skipped a step. If you really want to expand it, I really should have done 5 times x, shown it like this first, plus 5 times 1. So I really should have done this. This is truly the expanded form. So I apologize. Got ahead of myself. it's easy to get ahead of yourself. So you have to be really careful if it's asking you to show expanded form to make sure I did not. This is expanded form, and then this is evaluating it. I'm taking 5 times x and writing it simply, and then I'm taking 5 times 1. Oh, sorry, someone just walked in my door. My dogs are barking. Okay, so this is some addition problems. So now we're going to try a couple with negative numbers. Oh, yeah, both of these were addition, but you would do the same thing with subtraction. I should have done one addition, one subtraction. Now we're going to look at negative numbers. Yay, negative numbers. We're going to do the same thing. I'm going to take negative 6 and multiply it by positive 3. And then I'm going to take, well, I'll go ahead and do that over here. Negative 6 times a positive 3 plus negative 6 times the 7. So you take that negative with it. It goes with the 6 because it's part of it. Okay, that's a terrible x. Multiplicate. Okay, so this is expanded form. Now if I want to evaluate it, okay, I'm going to eval. I'm just going to abbreviate eval. There really is a V there. You just can't see it. I'm messy. Okay, so I'm terrible. All right, so I'm going to multiply my negative 6 times 3. Negative times a positive is a negative, so this is a negative 18 plus, okay, don't forget to keep that plus sign, okay, negative 6 times 7 is negative 42. I'm not going to put that in parentheses just because I've got a plus sign there. I don't want to have like a plus negative. They just kind of get crowded. And then that last thing I need to do is add my 2 negative names. Oh, negative numbers. And I started thinking of the song again. Are y'all thinking of the song? Who's singing the song in their head? Same signs, add. We don't even need to sing the next verse of the song. It's just same signs, add. So we're just going to add them together. So when I add negative 18 and negative 42, I get negative 60. So would that work out if we just did order of operations? Yes, because 7 plus 3 is 10, and 10 times negative 6 is negative 60. So these are great because you can actually check your work and make sure you expanded it properly. If you can come up with the same answer of just solving it like just using regular order of operations. So that's kind of nice. Let's try another one with negative numbers. Let's do negative 2 times 5 minus 2. Okay, now this one gets kind of tricky. All right, again, I'm going to do negative 2 times 5, and then I'm going to do negative 2 times 2. Okay, in this situation, this is just a subtraction sign. We're not going to make this negative at this point. Just hang with me. So let's expand it. Negative 2 times 5, in parentheses, minus, okay, this minus sign is going to go over here, minus negative 2 times 2. Don't take this with it and thinking that's a negative 2. We're going to leave this minus right there. Okay, so then my next thing would be negative 2 times 5 is negative 10. Right? I'm going to go ahead and put these in parentheses just because there's a bunch of negatives and I want to keep things together. Minus, that's coming down here. Then in parentheses, negative 2 times a positive 4 gives me a negative 4. Okay, and you can see why I wanted to keep it in parentheses because I knew that I was going to have minus and negative. And this is where you've got to remember your rules for subtracting and adding. This is the same as saying negative 10 add the opposite plus 4 equals negative 6. Does that make sense? Yes, because 5 minus 2 is 3. 3 times negative 2 is negative 6. So you have your own built-in check system. Okay, one more. What about fractions? Can I do fractions? Sure, I can do fractions. Where's my notes on fractions? Here we go. Okay. So again, we're going to do 1/2 times x and 1/2 times 4. How do I do 1/2 times x? Well, it just becomes 1/2 x. Okay, so my expanded form over here is going to be 1/2 times x. I'm going to use my dot because x looks like a multiplication sign. This is addition, so I need to use addition here. 1/2 times 4. I'm just going to use dots here because they really are going to be less confusing. I recommend you use dots once you start getting variables. Okay, so now I want to simplify it or evaluate it. Okay, evaluate. 1/2 x, there's nothing I can do as long as I don't know what x is, so simplifying it is just 1/2 x. Plus 1/2 times 4 is just 2. So this is equivalent to this, 1/2 x plus 2. Okay, and then last one, and then y'all are going to practice some. 16 minus 4p. Okay, I did a subtraction one. So we're going to multiply 1/4 by 16 by 1/4, and then we're going to multiply 4p by 1/4. Okay, so let's expand it. Oh, I forgot to put that up there. Okay, so I'm going to do 1/4 times 16 minus 1/4 times 4p. Okay, I got to keep the 4p together. I can't separate it out. Okay, then to evaluate it, which is, kind of like simplifying in this situation. Okay, so when I multiply 1/4 by 16, I get 16 over 4. I'm going to leave it like that just for a second. Minus, when I multiply 1/4 times 4, I get 4 over 4p. And then I can simplify it to 4 minus p. So this 1/4 times 16 minus 4p simplifies down to 4 minus p. So that's why you really got to be able to use these steps and expand it out. Okay, you really need to be able to do that because the things are going to get more complicated. Okay, how are you feeling? Hopefully okay. So I'm going to turn to this page. I've already got some practice problems. There's only 5 of them, but I gave you a challenge one. Oh, let me zoom out a little bit. You're going to pause, okay, and then you'll come back and see how you did, and then you'll be done with all of the instructional videos today, and then it's time to go practice a little bit. All right, pause and come back when you're ready. Okay, I'm guessing you're ready because you unpaused it. So again, we're going to solve these. I haven't solved these ahead of time, so I'm going to be solving them with you. I don't think I solved them. No, I didn't. So hopefully I don't make any mistakes. Let's expand this out first, and let's do 6 times 5 plus 6 times 11. Okay. 6 times 5 is, I'm going to go ahead and evaluate it. 6 times 5 is 30, plus 6 times 11 is 66. So then my answer is 96, which if you were to do 5 times 11 and do 16, 16 times 6, is that right? 60, yes, and 36, that's 96. Okay, so you can check your answer. All right, let's do this one. I should have paused this myself, but oh well. We're working through it together in case you didn't know the answers. So 8, this is 8 times t plus 8, times 9. Okay, 8 times t is just simplified to 8t plus 8 times 9 is 72, and that's all you can do. I can't do anything else because I don't know what t is. Okay, let's do some more. Remember, we're going to do 10 times each number inside the parentheses. Expand it out. 10 times 6 minus, this one's subtraction. Did you notice that? Minus 10 times d. Okay, so 10 times 6 is 60, minus 10 times d is just 10d. So that's it. That's all you can do. Okay, let's do fractions. All right, remember, 1/2 we're going to multiply 10x by 1/2 and 12 by 1/2. So we're going to distribute it out. 1/2 times 10x minus 1/2 times 12. Sorry. Okay, so now when I do 1/2 times 10, that's just 5, isn't it? Okay, so this just becomes 5x because the x just sticks with the 10 and we cut the 10 in half, minus, when I cut my 12 in half, I have 6. And there you go, 5x minus 6. Now this was a challenge one. I think I mentioned previously I wasn't going to show you how to go from expanded back to the simplified expression, but I do want to show you because I think there might be a couple of problems in the homework like this. So I can tell that 4 is being multiplied by z and 4 was being multiplied by 9. So 4 is my common number, which means it's my number that I need to start outside of my parentheses. I also see that this is subtraction, so I need to put subtraction here. 4 was multiplied by z. I'm sorry, z was multiplied by 4. Either way, I multiplied 4 by z, which means z was probably my first number, and 9 was probably my second number. And so you can kind of check it and think, okay, does that make sense? 4 times z, yes, minus 4 times 9, yes. So hopefully you got that one. All right, that's it. My brain hurts, your brain hurts. Take a break and mark this as done, and then you've got some practice problems to do. Yeah, good luck. Let me know if you need any help. Bye-bye.